All right, yes, good morning. I'm Spoons, AKA Daniel Spoonhower. I'm the CTO and one of the co-founders at LightStep. I'm not going to talk too much about LightStep. If you haven't heard of us, we are simple observability for deep systems. I am going to talk about observability, not surprisingly. And I'm going to talk about deep systems too, which I'll describe in a minute. And that's because I think deep systems are really important to understanding how we should think about observability. I'm not sure there's a lot of observability skeptics in the room. But for those of you that are already all in on observability, maybe, or I hope that you can find something in this talk to take back and convince others on your team or in your org that observability is pretty important. My marketing VP made me put this slide in here. But maybe I should go without saying, I did want to remind people that there's a huge impact that observability can have on our users, whether that's understanding system health, improving latency, reducing MTTR, just responding faster. And all of those things have real effect on business outcomes, right? Whether that's happier users, more efficient code, just more productive teams. But wait, what? 70%? Seems like kind of a lot. Actually, we see this kind of thing pretty frequently. Like there's a lot of room for improvement. And it's not as though this particular code is terrible and this is a really smart person working really hard. So there's something sort of external, I think, that's happened. And I think to explain that, we need to zoom out a bit and to try and understand what makes 70% performance improvements pretty common. To do that, I want to talk about two different kinds of scale. I talk a lot about scale. I'm sure you all talk about scale a lot too. That could be scaling with more users, scaling with more data, scaling our teams, maybe scaling ourselves. But these two kinds of scale that I want to talk about are wide scale and deep scale. So as an illustration, this is a small body of water, and this is a larger body of water. So we take a puddle, we add some more water, we keep adding water, we get a pond, maybe eventually a lake, an ocean. And this is what I mean by scaling wide. And the thing about scaling wide is, though an ocean is a lot bigger, solutions scale in sort of the same way as the problem, right? We just need a bigger boat. Now, in contrast, here's another example. This is a village. It's an organization of people, their work, their lives. And here's a city. And this is what I mean by scaling deep. And the point is that a city is not just a bigger village, it's a different thing. So the way that I navigate a city, the way that I find information, the way that I find other people, doesn't just take longer. I need new tools to do that. So to step away from these kind of abstract examples, let me talk about software for a minute. So this is what software looks like when it scales wide. And you can think of these as sort of embarrassingly parallel cases. So trivial MapReduces, an easily shardable data store. And these do happen in real life, but from an observability point of view, they're pretty straightforward. But if you're adopting microservices, maybe you're in a serverless, maybe you have an architecture that looks a little bit more like this. Services that depend on services that depend on services, where each request is broken up over and over again. And that's so each of these services can focus on one thing and do that one thing well. Of course, part of focus often means delegating part of that responsibility to other services. If we look at real software systems, I took a handful of LightStep's users and looked at what their systems look like, and we see exactly this kind of pattern, right? We have these layers of services built on top of each other. And I think this is a fundamental change to the way that we're building software systems. In particular, this means that microservices at scale aren't just wide systems, but they're deep systems. And this is the kind of complexity that affords the opportunity for these kinds of 70% performance improvements. And I think it's really important for observability, but before I do that, I want to just mention some other ways that you might know that you have a deep system. And that is, what do deep systems sound like? What would you hear if you have a deep system? Well, you might hear someone say, don't deploy on Fridays. You might hear someone say, where's Chris? I'm dealing with a P0 and no one else knows how to debug this. You might hear, it can't be our fault. Our dashboard says we're healthy. You might hear this. You might hear this. Or you might hear this. These are all the sounds of uncertainty, right? The lack of knowledge about how the software was written, a lack of information about how it's behaving in real time. And what's happening? What are you feeling? What's your team feel in these situations? Well, you're feeling stress, right? Stress can be defined as responsibility without control. So if I draw the system diagram here again, as a service owner, What you control is really your own service or maybe services, maybe you have a handful of them. And these are the things that you can deploy new code, you can roll back, right? These are where you're at the driver's seat. But when it comes to performance of your service, you depend on all of the services that are below you. And so in terms of responsibility, that actually goes all the way down the stack. And even if you're not at the very top of the stack as a service owner, maybe you're somewhere in the middle, there's still a whole set of layers below you. And this is really what causes this stress, right? This difference between what you can control and what you're responsible for. So how have deep systems changed this? Well, as a service owner, what you can control has stayed more or less the same, right? You still own just this one or two or maybe three services. But as the depth of your system increased, the scope of your responsibility got bigger and bigger. And not just linearly bigger, but because of the number of services that you depend on, because of the number of services that those services depend on, and so on, because of the interactions of all of those services, the gap between what you control and where your responsibility lies is growing geometrically. And this is, I think, why we need to think about observability in a different way, because the point of observability is really to shrink this gap, right? To provide the information, to give users better control, to let them understand their responsibility. So what does success in this case look like? Well, we can go back to our users, right? So success means that our users can quickly understand the health of their platforms, they can find the bottlenecks, they can understand latency, they can respond more quickly, they can improve MTTR, and they can deliver improvements in performance and in latency. So if we think about what that success means, it's really about these use cases, right? So as observability practitioners, how can we help our users be more confident when they release new code? How can we help them respond to incidents more quickly so they can achieve less downtime? Maybe it means avoiding incidents altogether. How can we help them optimize their code to provide a speedier experience to their users? And telemetry is the raw material that can help answer those questions. One of the things that's really exciting to me about OpenTelemetry is that we finally have a way of talking about logs and metrics and traces all in a unified way. And while more telemetry is often better, I think it's important to think about how that telemetry is addressing these use cases, how it's answering those questions. Part of the reason that the responsibility curve is growing so quickly is that teams find themselves often responsible for monitoring and understanding the performance of all of those other systems below them. And that's just not something that's realistic to expect or in a lot of cases even feasible. So in these deep systems, there are just too many signals, and part of the role of an observability tool is really to help identify which of those signals will matter. Okay, so just to kind of sum up, so microservices scale deeply, and it's not just microservices. Like I said, if you're using serverless, if you're building on top of hosted services, anytime you're creating layers upon layers where there's a separation of ownership, a separation of control, you're really creating the opportunity for a deep system. And deep systems are not just bigger, but they're different as well. And that gap that they create between responsibility and control is really what leads to the stress for users in these cases. And finally, observability has to help shrink that gap. And I don't have a lot of time to get into it now, but I'm happy to talk about it later if you grab me. I think that traces are really critical in providing the context for those kinds of use cases and problems. Again, finding the right signals so that we can help users navigate to the solutions they're looking for quickly. So I just wanted to quickly plug and remind everyone about the reception tonight, starting at 5:30, just across the tracks at the Whiskey House. Please bring your badge. I'll be there. I hope to see others there as well. Thanks for your attention. I'm looking forward to a lot of good talks today, and thanks.